Hello and welcome to Sudo Up the Call Stack, your place for programming news, tutorials, and help. I'm going to be your host for this particular video. I'm ZenOokami, and we're going to teach you guys the basics 101 before you even pick your languages, instructions for programming. Today we're basically going to go over the simple know your language. Okay, so just for this particular video, we're going to be using Python because it's really simple, really easy to show out, and it's basically easy for everyone to learn. So if we go here, this is our blank editor. This is idle. So first off, when you're programming, you want to know how to at least do one thing, and that is how to do a simple hello world program. It varies between different programming languages you use. So with Python, it's really simple. It is the print command. I'm going to save that, and we ran it here, and it went hello world. We'll do it one more, again, so you can see it. Awesome. So what is the purpose, or what is one of the main foundations in terms of making a program or a script or something? Well, the main purpose is to know what you want to do. Programs are basically algorithms. You code something, you want to make it easy to edit and change, to understand, so when you come back and look at it, you know what you did, why you did that, and what it's used for. So in terms of that, today we're going to be doing a basic decimal to binary converter, and we're going to go ahead and break things down in terms of how do we make this. So again, we're using Python, but before we go ahead and make the program, we have to know how decimal to binary conversion actually works. So what I'm going to do is I have Paint open up over here, and we're going to have our calculator up. Oops, sorry, my mouse is being kind of dumb. Anyway, so let's say we have the number, what's the easy one? 3. We have the number 3. So essentially, in order to convert a decimal number, decimal meaning anywhere, basically 0 through 10 in terms of digits, binary is basically 0 or 1. Okay? If you want to get technical, decimal is actually 0 through 9, but you guys get what I'm saying. There's 10 digits to choose. Yeah, whatever. So in order to convert decimal to binary, what you guys want to do is basically divide the original number by 3. Not by 3, excuse me, by 2. So you have the number 3, you divide it by 2. This is going to give you 1.5. Just so we're showing you guys this. Why did I write 3 again? Not 3. But 2. Sorry about that. And I get you 1.5. If the remaining number is anything like, if there's a 0.5 behind it, you know that decimal in terms of binary, you're going to have a 1. So then we take 1.5, we drop the 0.5, and you just go ahead and do 1 divided by 2. And this equals 0.5, which will be another binary 1. So then you go backwards and say this was the far left and this was the far right. So in binary, it equals 1. Why does it keep doing that? 1 1. Fair enough. A different way to look at it is the number 4. Alright. 4 divided by 2 equals 2. So since there's no 0.5, you know in binary this digit will be 0. Okay, so then you take 2 divided by 2 equals 1. Right? And since 1 has no 0.5, you're going to go ahead and say the binary number is again another 0. So then you take 1 divided by 2, and then it's going to equal 0.5 again. And then this is going to be a 1. I'm so sorry, I don't know why this keeps making like this weird shape. But then essentially going backwards from bottom, which is the far left, up to the top, which is the far right, you know in binary is going to equal 1, 0, 0. Okay, so now that you have your algorithm, which is basically take a number divided by 2, if it's greater than, or if it can be moduled by I think is it 3, you'll know it's going to be a 1. Otherwise it's going to be a 0. So we're going to go back and open up our IDE, or rather the scripting language itself right here, and this is where you want to go into here. This is your the console for Python. You want to do some testing. So basically, you know that let's see, 3 divided by 2 equals 1.5. Yes. So let's say 3 module 3 is 0, or rather, is it 3 module 2? Just 3 divided by, because 3 divided by 2 is 1.5. Right. So basically 3 module 2 means that when you have 3 divided by 2, will there be a remainder? 1 means yes. So you can also do 5 module, as soon as I type the right key, because 5 divided by 2 is 2.5. So now you have your pattern. You know that you have the tools that you know that you're looking for. Alright, so now we need to go ahead and just set things up. So what I usually like to do is type my my comments. Comments is basically things that are ignored by code, and you can learn this out in further programming tutorials, but this is just, you know, basic knowledge. So we're gonna have simple decimal, or just do dec to bind converter. So it's supposed to be O. Forgive me if the spelling is incorrect. So let's start out. Let's go ahead and now let's see, how do I want to make this program? Nothing is, you know, in my videos nothing is pre-scripted. So right now I'm thinking, how do I want to make this program? You can make it where you just have raw code and edit as you go, but I like to make things a little bit simpler and easier to edit. So I know I'm going to have a function, you know, a specific task, a specific algorithm that creates a binary for me. You know, takes a decimal number and put it into a binary. So I know I'm going to pass in a number, a decimal number, and it's going to return a binary number. Alright, so what we're going to do is we're going to create this function, and we're going to call it decimal to binary, and we're going to pass in a number. Now some people use camel case code, some people use underscore. Personally, I like to do underscore. It makes things even easier personally for me to read. So alright, I'm not, spoiler or warning, I'm not the best programmer in the world, but I know a thing or two, so hopefully this helps you out. Let's see, we're going to have a list, which is basically what it is, a list of data, and we're going to call this the binary list, and we're just going to be set to empty. So make empty list, and we're going to have an old number and this basically helps us remember, so every time we go to the next division we don't lose track of the old number. And we're going to create a new number after that. So reference number. Okay, so we know we're going to have a loop. So in our loop, we're going to divide until we get down to that, 0. So if it's going to be 0.5, we know we're going to have a 1 left. But if it's lower than that, it's going to be a 0, which is going to be the end of the binary number. So we can just say while number is greater than 0.5. I think this is it. Loop. So basically it keeps checking, and then once it gets down to that, the number is now 0, which is the end of the binary list, it goes, okay, I'm done. So while that's not happening, so while the number is still going on, or the conversion is still going on, we're going to take our number. So remember we did the module, that's the percent sign, to say if it is modulo by 2, if it's going to equal 1, then we know it's going to be a 0.5 number. So we know that the binary number is going to be 1. So that's what we're going to do here. We're going to check that. So if our number moduled by 2 equals, no, does not equal 0. And I know we use 3 for an exception, but we can also do 2, and I'll show you here. So let's say if we do 5 moduled 2, we get a 1. Same process. Well, yeah, we did do that, didn't we? Right. So basically when it's not 0, so if it's 1, that means it's a 0.5. If the number is a 0.5, we're going to use our binary list, and we're going to attach a 1 in it, because we know if it's not 0, it's a 1. So we know that our binary number in this position is going to be a 1. And I do apologize if this is going to be a long video, because I'm programming this directly from my head. I didn't prepare this. I probably should have. So we're going to call, I think, yeah, that's going to be it for that one. Else, so basically if it is a whole number, one that does not have a 0.5 behind it, so basically if number module 2 does equal 0, we're going to add a 0 to that list. And append simply means add whatever in these parentheses to the list, which is binary list. So yeah, that should be it, I do believe. Hopefully it runs smoothly. So then we go ahead and then divide the number by 2. And basically this means like slash equals means, I don't know how to put it. So basically I wanted to make sure I was doing this correctly. So this is how I'm going to explain it. You probably know that the slash symbol means divide, and this equal sign basically means we're going to divide our variable number by 2, and we're going to set the variable number to that answer. You'll learn more about it in our tutorials, I promise, but I'm trying to make this as short but as informational as possible. So yeah, now that we have that, that's going to set the variable to the new number. And let's see, we're going to, an easy way to do it, because when you do divide by 2, you can basically get a float from it. So by doing number equals int number, we can get rid of the floating mechanic. So it makes it back to a whole number. Remember when we did this over here, how we dropped that 0.5? That's what we're doing again. So we're dropping that 0.5. Alrighty. Darn mouse. Then we're going to add a print here. And this is basically the check where I usually always do this. I add a checking mechanic during the alpha or the builds, excuse me, of a program of mine. And this is just to make sure everything is functioning correctly. And then we're going to do a print right here. This is basically a space. Once that's done, we're out of the loop because this is going to restart. Like from here, we're going to jump right back up to here. We're going to check to see if that number is greater than 0.5. So if it was, the last number in the binary tree is going to zero out to be 0. Come back here and say, yeah, I'm done. If not, it's going to go through this again. It's going to module by 2. If it's a 0.5, we're going to add a 1, and then we're going to take the number, which is going to be a number point whatever, divided by 2, and it sets the new variable number. Then we get rid of that 0.5. So if you're confused at this point, like you're asking, well, when we did this before, if we do a module of the number and it gives us, the 0.5 reading, we know there's going to be a 1. So why are you setting a number divided by 2 again? So to go step by step, let's say we have a number 3. Number is greater than 0.5. Yes, it is. Okay. So then we do 3 module 2, which will be a 1. So we know that 3 divided by 2 is 1.5. So we're going to add a 1 here. So now that we've done the 3's place, or the number 3, we need to go ahead and divide that by 2 so we can get to that next step, that next binary digit. So once you do that, we're going to have like right here. At this point, 3 will equal 1.5. Now, when we do a module check, we do modules on whole numbers, remember? So like when we drop that 5 over here and we brought it down to 1 and we did the whole check again to see if it's going to be 0.5, that's where we are. And this is the basic steps in terms of algorithm. And that's basically all you need to know in terms of this basic tutorial, which is getting a little bit more complicated than I wished for. But you can leave now, because that's basically what programs entails, a lot of problem solving, algorithms, and correcting yourself. But if you want to finish out this program with me and learn how to do something extra, you can stay for a little bit more. So we've got our main function done. So now we're going to print ourselves a little reminder. The binary form 4, we're going to space that, create a string, and then we're going to use old number because this is the number that we started with for reference, plus, now we're going to do our continuation of the string. And just so that because I don't know about Python setup, I think I could have done a plus and then used like printing the binary list in terms of that backwards, because like I said, we've added these digits to a empty list, but it would have added it backwards. So the binary number would be like, if we did 4, it would be 001 right now. So we gotta put it in reverse. So we're gonna take that and do binary list 1. Alrighty, and that should print the list to show correctly, I do believe. Alright, now we just gotta go ahead and do our main program. And again, this is Python. You don't really, it was any language, you don't have to have a main function, but it's good practice. So we're going to create a function, call it main. It's not accepting anything. Let's see, how do I want to do this? I know it's not so simple in terms of how I'm explaining it. I really should have created this beforehand. But we're going to have a system where a person can keep adding numbers to convert. So we're going to have a switch here. Switch, and we're going to have it equal out to 0. So while our switch equals 0, number equals int. It's going to be an input. Please input a decimal. Alrighty. Make sure we double parentheses close that. Yeah, so we're going to call our function here. So we do decimal, to binary. Did I spell that right? No, binary to. Yes, so decimal to binary, and we're going to add number, yeah. And that'll call the function, just for reference. Calls our function. And I think that's basically it. But since we're going to have this set up so people can keep asking questions, or keep inputting numbers to convert, we're going to have a variable called question. And this is basically another switch, but it's a more thought out switch. So we're going to call it question. So while question equals 1, we're going to have a user response input or raw. This is Python 3.1 or 3.3, so yeah, we're using normal input. Which you like to convert another? Yes or no? And then we're going to add this little thing over here called .lower, and this basically means that someone types yes or no, they might have the capital Y or capital no, but just to be sure that there's no problem in terms of their input, we're going to make sure that whatever they input, we're going to lowercase everything. So even if they type like yes or yes, yes or yes, no matter what they type in, it's going to be all lowercase. So then we're going to have our little space. If user response equals yes, then switch will be set to 1. So this thing, no, switch equals to 0. So that it keeps looping. Then question gets set to 0. No, set to 1 because we're still continuing. No, we can set it to 0 because we're done with this particular section. So if user, and you can do a copy and paste of your last one there, because I spelled something wrong. There we go. Equals no. Then the switch will equal 1. Switch will equal 1 to stop the loop. Our question switch will still be set to 0 because we don't have to ask this question over again. I think I need to have an Elif, and actually Elif basically means else if. almost forgot that in terms of Python. And then we're gonna have our else statement all together. So this basically means they input something incorrect. So they probably misspelled yes, they probably misspelled no, they probably typed the number by mistake, etc. So in case that happens, we're going to have them print, we'll have the computer print invalid input. Try again with the exclamation point because the computer is yelling at you. And then we're going to set question. We're going to make sure that stays 1. So basically while this is 1, this keeps happening. So in case they mess up, they can actually do the right response without crashing the program altogether. I think we're almost done. No, I think that is it. Yeah. So print finish just to check, and then we're going to save this, and then we're going to call main. So now we're going to test it. So please input a decimal. We're going to try 3, and if you remember, 3 is 1 in binary. So there we go. All right, so we see here, please input a decimal, and if you're going to follow our code, we input 1. From there, let's see, we can put a decimal. We go ahead and call our function, which is 3, and then we set our empty binary list. We have an old number, so old number will be 3, and then while 3 is greater than 0.5, we're going to check module it. So if so, the number is a 0.5, so it's going to append 1. Go down here, divide the number by 2, which now is going to be 1.5 at this point. We go down, turn 1.5 into 1, and then we print the binary list to make sure we know what it's doing, and that's right here, binary list. It goes back up. Is 1 greater than 0.5? Yes. When you module it, does it set equal to 1? It does, because 1 divided by 2 is 0.5, so we add another 1, and then we go down here, divide that by 2, which is now 0.5. Go ahead and make it into an int, so we get rid of 0.5, so now it's just 0. Now we print our binary list, and then we have 1 1, and then we go back up. Is 0 greater than 0.5? No, it's not. Screw this loop. Go down here. The binary form for string old number is our new binary list. We want to do another one? Yes. This time we're going to do 4. And you see how when we did everything, it loaded in as in 0 0, then 0 0 1. Etc. Because that's how we did our steps again, and then we had to flip it around because bottom up, left to right. It is now 1 0 0. You're gonna type no because we gotta check everything. Matter of fact, I'm gonna show you our safety option, the one with the question switch. If someone mistypes the input, invalid input, try again. Gonna type no in all caps. We're finished. So that basically wraps up our 28 so minutes of learning something really basic. If you enjoyed what you saw today, if it helped you out any way of manner, please leave a like, comment below if you have any questions, subscribe if you wish to see more. We're going to be doing more tutorials as it comes by, but we're still busy with getting ready for college again for the new semester. I'm also working, so I don't have as much time as always to do this. And this program will be uploaded and will be added to the description below for you to download and actually mess with, play with, modify, test things out for yourself. It'll also be on our GitHub, so feel free to use it, learn from it, etc. Thank you guys for watching. This has been Sudo Up the Call Stack, tutorials on programming and etc. Thank you for also watching. You guys take care.